Okay, so I'm going to answer a question that I had, and it was over covalent bonds. So they were asking about um, what you have to do and how balanced it has to be. So we're going to work two different covalent bonds, and we're going to talk about why we're doing them. So first of all, covalent bond is always going to be between nonmetals, and so carbon is a nonmetal, and oxygen is a nonmetal, so nonmetals. And then over here, sulfur is a nonmetal, and oxygen is a nonmetal. So I have two different covalent bonds that we're going to work. So each time we're going to set them up the same. So we need to first figure out how many total electrons we have. So we're adding up our bucket, and then we're going to connect them all with lines. And so we're going to go through and just break this down and make sure it makes perfect sense. So I want you to do each step. So first I need to see how many valence electrons they have that are going to interact with each other. Because remember, valence electrons are those outer electrons, and those electrons are going to be the ones that interact with everything else and form bonds. And that's for ionic and covalent bonds. Those outer valence electrons are the ones reacting. And so we need to figure out how many valence electrons we have. So carbon has 4 valence electrons, and oxygen has 6, so I'm going to add it twice. It's going to give me a total of 16 in my bucket. Okay, so my next step is to connect them. I hope y'all can see that, it's not too far away. And so then my next step is to connect them all. So again, I'm going to put oxygen on the outside because I have multiples of those, and carbon's going to go on the inside as my central atom. Now then, I automatically connect them with a line. This line represents 2 electrons. It's 2 electrons that are being shared. When we're sharing something, for this case, for diagrams, we use lines. So this is saying that 2 electrons are being shared. So right now there's 2 electrons here. So that means that oxygen's in possession of 2 electrons, and carbon's in possession of 2 electrons because they're sharing. And when we're sharing something, both people are in possession of it. If I had like a little toy car, this isn't a toy car, but I was playing with it, and I was playing it with my nephew, me and him would both be in possession of the toy car. Okay, and so we would both have one toy car that we're playing with. And so they both have 2 electrons that they're sharing, they're playing with, whatever. And so oxygen has 2, and then carbon has 2 from here, but carbon also has 2 from here. So in total, currently, what we have right now is 2, 4, and 2. These are their electrons. So remember, they want to get to 8. Now, on my actual diagram represented, I only have 4 electrons actually represented, because if you look at your lines, 2, 4. So I've used up 4 out of my 16, so I have 12 left to use. My next step is to just give octets. And so how I'm going to give octets is I'm going to do electrons. And we represent electrons with little dots. Either we represent them with lines or dots. And so in this case, since they're not being shared, they're just going to be dots. If they were being shared, they'd be a line. And we're going to keep them in pairs. So I need 12 more. So I'm going to go here and go 2, 4, 6, and then we're going to jump over here, 8, 10, 12. And so now I've used up my whole bucket, so we can count that and make sure we have 2, 4, 6, 8, 10, 12, 14, 16. I've used up 16 on this diagram. And so I want to make sure everybody has an octet. So oxygen does have an octet. It has 2, 4, 6, 8. Because remember that line counts as 2. And this oxygen has 8, 2, 4, 6, 8. Carbon, however, still only has 4. It just has these 2 lines. So we're going to share. And the question was, do we always have to share and make it equal? And the answer is, if we can, yes. And so this is the example of where we can make it equal. And so so I need to share. So then oxygen's going to be nice and say, hey, this pair of electrons, instead of keeping them all to myself, I'm going to let you play with them too, carbon. So we'll put them in the middle so we can both play with them. Now then, that gives carbon 6. So oxygen still has 8, 2, 4, 6, 8. And this oxygen still has 8, 2, 4, 6, 8. This carbon now has 6. It needs 8, so it needs 2 more. So there's 2 different options that we could do. One's right and one's wrong. I'm going to show you both of them. And so this guy could say, hey, let me redraw my molecule. So this guy could say, hey, I need to share 2 more. And it could share 2 more. And so then carbon has 8, 2, 4, 6, 8. Oxygen has 8, 2, 4, 6, 8, and this oxygen has 8, 2, 4, 6, 8. But in reality, in nature, that's not going to happen. Why would this oxygen give up so much more when this oxygen had to give up so little? It's not going to happen. And that would be the wrong one. So what actually happens is this oxygen says, oh, you need 2 more? I'll also share. And so we have equal sharing. So see how it's even? If we can make it even, we're going to. So now we have double bonds on both sides. So that's an example of when we can make it even. And so when we can't necessarily make it even, that everybody doesn't get the same type of bond, would be over here with SO3. So it's a covalent bond, so we're gonna add up our bucket. So we're gonna do this. So sulfur has 6 valence electrons and oxygen does, so I did 3 for oxygen, which would be 24 total. You can pause the video and check my math if you'd like, but 24 total. So then we are going to connect them each to the central atom. Okay, so now I've used up 6, 2, 4, 6. So now we're going to start to give octets. So I'm going to go through and say 2, 4, 6, 8, 10, 12, 14, 16, 18, that's 20, 22, 24. So I've used up 24. You can double check. I used up my bucket, so we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now then, I have single bonds. Oxygen has an octet, each oxygen has an octet, but sulfur does not. Sulfur only has 6, 2, 4, 6. So I need to give oxygen or sulfur just 2 more. So that means just one oxygen has to share. And so for instance, this oxygen could share. Now, is it all even? Is it all symmetrical? Is it all pretty? No, it's not. Only one oxygen had to do a double bond. The other 2 got to stay single bonds. But does everybody have an octet and I only used up 24? Yes. And so there's an example of where you would maybe have uneven sharing. And so hopefully that answers the question that was typed to me in the Zoom chat. If it doesn't, then I can always create more videos. But hopefully that kind of clears some things up and we can get better at doing these, okay?